Hello. Let's make a start on the next topic, which is simultaneous equations. Now, as it says in the instructions here, simultaneous equations contain equations with two or more letters, which then must be calculated. Really, in National 5 and higher, we will only ever deal with two letters where we need to work them out. When we get to advanced higher and beyond, then you deal with working out three letters, four letters, and so on, using a process called matrices. We don't need to worry ourselves about that just now. Basically, simultaneous equations are just two equations with two unknown variables. The one thing about any equations is we cannot work out the solution to an equation without eliminating or getting rid of one of the variables. So if you have an equation that has x and y in it, then you can't solve for x if you don't know what y is. And you can't solve for y if you don't know what x is. So you have to find a way of eventually getting rid of them. More about that when we get on to solving them using algebraic methods. This video is all about just solving them graphically. So what we have here is a simultaneous equation deals with really straight lines. The official name is simultaneous linear equations, L-I-N-E-A-R. And you've seen that word before, linear, straight line. When we're dealing with that topic, really we can just solve simultaneous equations by drawing the straight line. And wherever the two straight lines meet, that's where the solutions lie for both x and y. So this example here, I want to solve these equations by drawing the straight line equations. The first one, y is equal to x minus 2, which I'll do in blue, and y is equal to minus x plus 6, which I'll do in green. So, if we were in the classroom, I'd be saying to you, how do you draw a straight line? And I'm sure every single person would be able to tell me, here's how you draw a straight line. You draw them, first you find where it cuts the y-axis. So, when do lines cut the y-axis? We know it's going to be whenever x is equal to 0. So let's write that down. So we can say that line cuts the y-axis when x is equal to 0. So that's going to give me y is equal to 0 minus 2, so y has to be minus 2. So the first point, the blue line is going to cut the y-axis at the point 0 minus 2. We can find where it cuts the x-axis by doing the same kind of thing. So I can say that line cuts the x-axis when y is equal to 0. So let's set y to 0, so we just get x minus 2 is equal to 0, so x has to be 2. So that gives us 2, 0. So that means the blue line is going to cut through the point 0 minus 2, and it's going to cut through the point 2, 0. And we can then join those up, and that will just give us a nice straight line. Hopefully if I can do it right. Next one we'll do in green. The line y is equal to minus x plus 6. So I can say that the line cuts the y-axis when x is equal to 0. So y is equal to minus 0 plus 6. So y is equal to 6. So it cuts the y-axis at 0, 6. 1, 2, 3, 4, 5, 6. And the next bit we can say it cuts the x-axis. Line cuts the x-axis when y is equal to 0. So that's going to give me 0 is equal to minus x plus 6. So x has to be 6. So it cuts at 6, 0. 1, 2, 3, 4, 5, 6. So it's cutting at 0, 6, and it's cutting at 6, 0. And then we just join those points up. Now, forgive my slightly dodgy graph skills. You know what I'm like. It should be cutting through that point there. I'm sure you've done it a lot better than I can. So it's cutting there. And if we see what coordinate that is, that's going to be the coordinate, count along, then up. 1, 2, 3, 4, up 2. So it cuts at the point 4, 2. So therefore the solution to that is, the solution to these simultaneous equations is going to be x is equal to 4, y is equal to 2, because the two lines pass through the point 4, 2. And that really is just how you how you solve simultaneous equations by sketching them out. Let's look at the next example on that then. The next example, this time the lines are, the equations are slightly more complex. They're just not in the format of y equals mx plus c, but that shouldn't matter to us because we know how to sketch straight lines. So let's do this one here in blue, and we'll do this one, we'll do it in red this time, just because it's example 2. Right, so let's start with the blue line. So I can say that the line cuts the y-axis when x is equal to 0. So that's going to give me 4y plus 3 times 0 is equal to 16. So 4y is equal to 16, so y is equal to 4. So that's cutting the y-axis at the point 0, 4. 1, 2, 3, 4. Cutting there. Let's find where it cuts the x-axis. So I can say that line cuts the x-axis when y is equal to 0. So do the same thing. So it's going to be 4 times 0 plus 3x is equal to 16. So that's going to give me 3x is equal to 16. So x has to be 16 thirds. So we really know that 16 thirds is the same as saying that x is equal to 5 and a third. That allows us to place it a bit better. So count along 5, 1, 2, 3, 4, 5, and then a third, which will be approximately here. Okay, so let's join those 2 points up, and it should look something like this. Again, apologies for my dodgy line drawing. The next one, 2y minus x is equal to minus 2. So let's just do the same thing. So let's find where it cuts the y-axis. We know, again, line cuts the y-axis when x is equal to 0. Okay, so let's set x to 0. So we get 2y minus 0 is equal to minus 2. So 2y is equal to minus 2. So y has to be minus 1. So it cuts the point here at 0, minus 1. And then we can say that line cuts the x-axis when y is equal to 0. So let's set y to 0. So we get 2 times 0 minus x is equal to minus 2. So if minus x is equal to minus 2, x has to be 2. So it's going to be the point 2, 0. And then just join those points up. And it should meet nicely if my dodgy line drawing doesn't affect it. Ah, look at that. Perfection. So it's cutting here at the point 4, 1. Okay, so put the solution down. Let's get this communication mark because this question is asking us find the value of x and y. Well, the coordinate is 4, 1, but we have to actually state the value of x and y. So I can say, therefore, x is equal to 4 and y is equal to 1. That is the solution to the simultaneous equations.